male, female, male, female. So what is the peculiarity of this vector? This is a character vector. It's very simple, having values male, female, female, male, etc. But the peculiarity is that elements are repeated. That is, if you take the unique elements, there are only two unique elements, male and female. All the rest are repetitions of the, or they are basically using the same discrete values, male and female. It's repeating the discrete values, male and female. So it is a discretized vector. It's not a continuous vector. It is taking input from a discrete set of values. You don't have so many values to play. Only two types are there. So such kind of values, suppose I want to make a vector of citizens of length 200. What you will do? You will simply type male, female 200 times. And then do you think the computer is going to save the entire 200 characters? So here, as you can see, M-A-L-E, there are 4 letters of the word male. So imagine that one letter costs 1 byte. Then the word male costs 4 bytes. And the word female costs 6 bytes. So for a single male value to be stored, you need 4 bytes. So likewise, if you have 100 males and 200 females, imagine the amount of memory that a computer should have for storing this vector alone, for storing the citizen vector alone. So it's very tedious and it is very expensive. So to avoid that, computer is storing such kind of categorical data in factors. Factors are simply numerical values associated with the labels. For example, it is saving 1 instead of a male and 0 instead of a female. So whenever you say 1, you mean a male. So whenever you want to print 1, you just need to fetch a 1 from the factor. So it will print the corresponding character. That's it. So you can view the levels. So if I create a factor from the countries, and if I type citizen, see, there are only 5 levels. It's called levels. So levels are nothing but unique values of the factor. So in this factor citizen, there are only 1, 2, 3, 4, 5 unique values. Even though the length of the vector is 7, there are only 5 unique values, which are Australia, China, India, Japan, and USA. And you can see that they are sorted in the alphabetical order by default. So you can change the way it is sorted, or you can change the sorting order also by explicitly giving levels equal to C, male, female. So here also the problem is there. Male, female, if you take female is having an alphabetical precedence because F comes in dictionary before male. So it by default group it as female, comma, male. So instead, if you want to have male, comma, female, you can give explicitly mention levels equal to C, male, female. That's the idea. So you can reorder. It's very easy to reorder levels in the way you want. So this is the concept of levels. And you can unclass, you can issue an unclass citizen. If you give the command unclass, then it will show you the individual, the vector elements. So for example, 3, 5, 3, 4, 5, 2, 2, 1. What is this? When I issued unclass citizen, it is showing like this: 3, 5, 3, 4, 5, 2, 2, 1. What is this? These are the corresponding indices which the computer is storing. Which means whenever you have India, it stores a 3 because 3 is because India is third in the alphabetically sorted levels. So internally, it is remembering the levels as Australia, China, India, Japan, and USA. And whenever in the vector I see India, it is substituting India for 3. That's it. And the reverse happens when I want to print the third element, or not the third element, when I want to print 3. It substitutes back the India and shows to us. This is the idea of levels. So it's the idea of factors. So it's a way of storing categorical data. It's a vector only, but it's another way of storing categorical data. And now we'll move to data frames. So frames is just like metrics, but it is like list to vectors. So list is the heterogeneous data type corresponding to vector. Similarly, data frames is a heterogeneous type corresponding to matrix. So in C, you have the matrix and struct, isn't it? So in matrix, you can't store one column as name and the other column as phone number. It's not possible. So if I declare a character matrix, everything should be a character. If I declare int a of 10, 10, 10, then that 100 elements of the matrix should be numbers. You can't have one column, first column as numbers, second column as names. No, that's not possible in C. For that, for consolidating heterogeneous data types, in C you have to use a struct or a structure We have studied struct or structured data type, which shows heterogeneous data type. Union is also there. So similarly in R, it is the heterogeneous counterpart of matrix. It's called data frame. So normally it is imported by reading a table from a spreadsheet or a large file, because usually it is used, data frame is used to input a file from an external world. So when it comes to big data, it's not possible to read in the values one by one from the keyboard. So we often use file operations. We'll see how we are reading a file after a couple of slides. So it accepts as input a file and normally reads the table, stores the columns of possibly different data types, and then we can use a view to subset the columns which we require. And data command is used to view built-in data types or built-in data frames. For example, iris. Iris is a data type that comes along with, that ships along with R. So iris is actually a type of, you might have heard, those who are familiar with data mining and machine learning might have heard that iris is a special kind of pea plant, pea or garden pea. Pea plant that is used to compare the sepal size, sepal width and petal width and size. So it's available free of cost in the University of California, Irvine, UCA repository for machine learning. So I've downloaded from that, but anyway, in latest R release, it is automatically shipped. So if I can simply type data of iris, it will show the iris data. It will load the iris data, not showing, it loads the iris data in the workspace. So now our current workspace is loaded with the iris. So if I simply type iris, it will show you the different values of iris. So iris has about 150 observations. There are 1, 2, 3, 4, 5 attributes or 5 features, we can say. These are columns. That, as I have mentioned, these are the characteristics of sepal width, length, petal length, width, and all in the species. So they have found out that there are 3 types of garden pea: Iris setosa, Iris versicolor, and Iris virginica. These are the botanical names of different kinds of pea plants. So there are different varieties of this. So there are 150 data items. That is why there are 150 rows. And then you can use subsetting here also. So if I type iris of 1 to 10, iris of 1 to 10. Sorry, you have to mention a column attribute also. Iris of 1 to 10. So this single quote or this column denotes it's a row. So since iris is a data type or data frame, it's just like a matrix. The subsetting is just like a matrix. You have done it before. The first you have to mention the row attribute. So here I'm mentioning the first 10 rows. And the next thing is the column attribute. So here I'm mentioning the first 2 columns. See, if I type like this, it will show the first 10 rows of iris and first 2 columns of iris. See, first 10 rows and first 2 columns of iris. So I can also skip the column attribute, iris of 1 to 10, and put a comma, just a comma. Then it will automatically show all the columns. See, all the 5 columns it is showing. Similarly, you could also skip the row attribute, then it will print the entire row, that is 150 row. That's the idea of data frame. And by subsetting, we can usually create a view of what all the columns that we have. And we can also type question mark for getting help. Say for example, if I type question mark head, then you'll get the syntax of the question mark. Syntax of the head command returns the first or last part of a vector, matrix, table, data frame, or function. So head and tail. That means if you want to say fetch the first say 5 or 6 rows, then you can type head of iris. And this is very handy because often you want to know, or often you want to see what is inside a file without opening the entire file. Suppose a file have 1 million rows. Instead of opening the entire file and loading or hanging the system, you can simply type head of iris. It will show you the first 5 or 6 rows. Also tail is there for the last 5 or 6 lines. This some of utility commands you have, so you can try it out. And now we'll move on to file handling. So how to read external files, or how to read files from external world, that is by use of the read.table command, read.table. So I have a wheat wheat.csv file. So it's a CSV file. So in my folder I have a wheat.csv. Wheat.csv. It is a comma separated file. It's an Excel file. I'm going to read it. I'm going to read that file by using the command read.table. So I can simply type read.table, the file which you want to read, comma. That simply one. I will say what is this header equal to true later. So if I simply read the table to a variable called w, no such directory. Okay. So I think I am not in the home directory. I am not in the directory. So I have to be in the directory where this file is residing. So I am in home documents invited talks Kidangoor ATAL FDP course materials. ATAL FDP. So then I have to give the full path. Then only it will open. For example, I have to give, or better I can cd documents invited talks DP. So now I am inside that. Now if I type R, so now my path is this particular folder where the file is residing, wheat.csv is residing. Now I can issue the command. See, now it has read the file. So if I type W, it will show you the file. So that file is an Excel file having 211 rows. 211 rows and 8 columns. 8 columns. So the columns are actually area, perimeter, compactness, length, width, asymmetry, some features of wheat. So wheat is a particular kind of what you call grain. So this is a data set I have obtained from the University of California, Irvine, UCA machine learning depository. Its features are area, perimeter, compactness, length, width, etc. of the grain wheat. So there are 8 features. So but you have observed or you have noticed the headers V1, V2, V3, V4. See why this happened means it is trying to read it as a table. And you see the number here, the header. So we know that area, perimeter, compactness, length, etc. are the header of this table. But unfortunately, R doesn't know that this is a header. So we have to tell R that R, this is not treated as number or data. This is not to be treated as a data. This is a header. So for that, you are mentioning header equal to true. Header equal to true. So if I mention header equal to true, now you see the difference. If I type a head of W, now you see the difference. Now the first row is not treated as a data item. See, numbering starts from here. There are only 210 items actually. This 11th one is the header itself that is treated as wrongly treated as the data item.